Vending machines. Vending machines. You put in $1, you click a certain button, and out comes what you want. It's a function. There are functions in so many places in this real world, and a vending machine is a very understandable example of a function. So what we're going to do today is we're going to continue talking about functions, specifically linear functions, those functions that have a constant rate of increase or decrease. So our learning target again is to construct a function to model a linear relationship between two quantities. And today we want to again work on determining and interpreting, so more along the lines of interpreting again, rate of change and initial value in terms of models that could be graphs or tables of values. So let's look at our problem of the day. This is beginning on page 365. So if you go to page 365 in your book, and you can take notes here. So let's read through this problem. It says Aretha is rappelling down the side of a cliff. Rappelling, I forgot how to pronounce it. Yeah, it's definitely rappelling. The graph shows her height above the ground in feet as a function of time in seconds as she descends down that cliff. So what is this problem about? Well, she's rappelling down the side of a cliff. So what does this mean for what we know about functions? Well, if I just look at this graph without even reading the situation, I might have an idea of what's going on. This person is, or something is going down in height over time, which is exactly what this is about. And since we know it's her going down a cliff, the next question is, what is Aretha's height above ground when she begins rappelling down, and at what rate does she descend? So what I'd like you to do now is to answer that question. What is her height when she begins? So that's the first question. And second question, at what rate does she descend? That's question 2. So why don't you pause, answer those 2 questions based on what we have in the graph, and be ready to explain what you did. So if I'm looking at this, her beginning height is her initial value. It's also the y-intercept on this graph. She begins at right here. That looks like it's at a clean 90 feet above ground. That is your initial value or your y-intercept. And the rate at which she descends is based on what we see. Now, I could pick any 2 points. It looks like it's going down and over, down and over, down and over. It's not 1 over 1, though. It is negative, but if you look at the numbers, it's going down 10 every 2. So negative 10 over 2 seconds. And that can reduce to negative 5 or negative 5 over 1. So she's going down 5 feet every 1 second. And that's our rate. And those 2 things are the most important things when we are dealing with a linear situation. Where you begin at, what's the initial value or the starting value, and what the rate of change is. So if you flip the page, there is some information here on how you could do that. What they took, one model in the book shows obviously the y-intercept is there, but then taking 2 points that you know on the ends and finding the slope that way using the slope formula. So y2 minus y1 over x2 minus x1. And this one is easy enough to do rise over run though. But just remember the rate of change, that is the same as the slope, and the initial value is the same as the y-intercept, or wherever the height is at 0 time. And you can put those in to make this equation. Y equals negative 5x plus 90. So these questions are related to that. Number 1, how can you determine what x and y represent in the equation? So what is x in this equation? What is y in this equation? Because variables always represent something. And the easiest way to look at that is to look at the graph. If I go back to this graph, the x-axis is talking about time, and the y-axis is height. So x is time in seconds, and the y is height in feet. So if you look at the rate, it would be height per time, or feet per second. Number 2, look at the model it and the analyze it, the two examples we just looked at in the book. What is Aretha's height above ground when she starts rappelling? We've already answered that, 90 feet. And at what rate does she descend? We already answered that as well. 5, you can put in 5 feet per second. You can put -5 because it is descending, but you understand if you say descending, it's going down. Number 3, explain how to write an equation for a linear function when you know the rate of change in initial value. Well, hopefully you remember y equals mx plus b, where the rate of change is the slope, the m, and the initial value is the y-intercept, or the b. B, describe how the rate of change and initial value of a linear function are represented in the graph. Well, the rate would be our rise over run, or our slope. And the initial value is that y-intercept, wherever it starts at the y-axis. So when x is 0, what number on the y-axis is it at? All right, so then there's the reflect question. Think of one of the models that helped you the most. What I want to do is jump straight to our second example, number 5. Go to number 5. I really would like you to try this on your own. It says the total monthly cost of exercise classes is a linear function of the number of classes attended. So you can see the table showing the costs for 2 different gyms based on every 5 classes you attend. These are all going up by 5. You can see there should be a constant rate. Now if I look at gym A, it goes up, I don't know if you can tell, it's going up by 75 every time this goes up by 5. Whereas if you look at gym B, every 5 classes attend, the increase is only 50, but somehow it's starting higher. That should tell you about something about an initial value. So part A, it says what is the cost per class at each gym? So let's take gym A. It says cost per class. The cost is going up $75 every 5 classes, which if you divide 75 by 5, you can divide them both by 5 and you get $15 per 1 class. Now I already ran out of room. So gym B, I'm going to make this go way over here and take up some space right there. Gym B is going up $50 every 5 classes, which is reduces to $10 per class. So why then is, after 5 classes, why is gym B more expensive? Well, it has to do with this 1 time a month fee. And that would come in for gym B. If you go back 5, you get to 0. So 0 classes. And if you go back one more here, you'll get to $60. That means it's $60 even if you take 0 classes. Whereas this one, if you go back, it would be $0 for 0 classes. So gym B has a $60 starting fee or monthly fee on top of the fee per class. But it is cheaper per class after that. So the more classes you take, the better off you are at gym B. So that's just another example of how you can apply your knowledge of linear functions to a table. So the last 2 examples, well, this one has to do with another graph. You got your y-intercept, and you can find your slope between 2 points here and here. There's a way to do it. But I want to just close it off with this last one. Mr. Sita plans a field trip for one of his classes. He rents 1 bus for the whole class and purchases a museum ticket for each student. The equation y equals 11x plus 400 gives the cost of the field trip as a function of the number of students who attend. So x would be the number of students, cost would be y. So what is the initial value of the function? What is the rate of change? And what do these tell you about the trip? So real quickly, because I think this is a really great problem. If you look at, because it deals with an equation, we already did a graph, we already did a table. Let's look at this equation and break it down a little bit. The initial value is the same as the y-intercept. So that's that 400. For some reason, it's $400 right away. And it says, what does that tell you about the trip? I don't know if it's a bus rental fee. It must be a bus rental, or that's my guess. Maybe a bus rental fee. So you don't have to pay for a bus per kid. You pay for a bus just for the bus. The rate of change, which is also our slope, is the 11. And that would be $11. We said it's based on the number of kids, so that's per student. And that tells us what that rate is. It costs $11 per student for a ticket. So that's going to be your ticket price for the museum. So there's definitely a price that you have to pay just to start, and then you have your tickets per kid. So breaking down and understanding from the problem what each of the parts mean. That goes back to our idea for today, our success criteria of determining and interpreting both rate of change and initial values. That's lesson 16.2. Have a great day, everybody. Go find a vending machine, input a button, and get out one output. Hopefully, that's what you want. We'll see you next time.